All right, so chapter 7 is about exponential functions, and also, I believe in this chapter is logarithmic functions as well, or is that next chapter? No, that's next chapter. So this one's all about exponential functions. If you look in your textbook, which is right here, okay, on page 332. Turn to page 332. Okay, so there's a little bit here on exponential functions and why we need them, why we have them. Okay, they can be used to describe and solve a wide range of problems. Some of the questions that can be answered are such. Okay, how much will your bank deposit be worth in 5 years if it's compounded monthly? Okay, so we're talking about exponential growth. It's not a straight line. It's a different shape of a graph. Okay, how will your car loan payment change if you pay it off in 3 years instead of 4? How acidic is a water sample, and so on. All these different types of questions. All right, so that guy's pretty happy about exponential functions. Okay, so that's great. This looks like some kind of military. I don't know, what is that? That's weird. A movie, 3D movie maybe? I don't know. It's probably explained here. 3D movie. Okay. Okay, so exponential functions. Okay, let's cut to the chase here. If you look on page 335, okay, graphs of exponential functions, okay, look like this. Now, when you talk about exponential, when you hear the word exponential, a lot of you might think of exponential growth, okay, or exponential decay. And obviously, the exponent function is very important in science. Very, very important. So it's worthy of our investigation. An exponential function typically would look something like this. If you go far left on the x-axis, the numbers are pretty small. And I'll explain why in a second. When you get to the y-intercept on a typical exponential function, this is generally 1. And I'll give you the format for this function later. But then after 1, you see it kind of starts to grow and the line gets steeper and steeper. Okay? So that's the general shape of an exponential function. And that format is y equals c, so some kind of constant, just a regular number, with the x as the exponent. And of course, that's why it's called an exponential function, because the root word is exponent. So the x is in the exponent position. Okay, that's important. That's what makes it an exponential function. And so if you get out your graphing calculators, you each should have one at your desk from the beginning of class. And let's just clear this stuff. I did mention at the beginning of class that you should grab one. That's okay if you didn't. But it means you either weren't listening or you weren't here. So no problem. Okay. So what I want you to do is I want you to graph y equals 2 to the power of, and here's your power of button right here, to the power of x. So just 2 to the power of x, and you can do maybe a zoom 6, which will get you to a standard window, so everyone's will look fairly similar. Okay? So that's what it's going to look like. That's y equals 2 to the power of x. Okay? 2 to the power of x. Now, if you notice here, let's check out what the y-intercept is. So second function, trace, that's the calculate menu. Let's go to value, and it'll say x equals, and plug in 0, and you'll see that the y-intercept is 1. Okay? So on your base function here, y equals 2 to the power of x, you have an x-intercept of 1. And then how do these other points come into play? Well, pretty easy. Okay, if you have x, y here, and let's say we chose x is 0, y is 1. Why is that? Well, because 2 to the power of 0 is 1. Any constant to the power of 0 is 1. That's why it doesn't matter what c is. If there's no other number in front multiplied here, or no other numbers added afterwards like this, you're going to have a y-intercept of 1. Now the other values, like let's say -2, and let's say 1 and 3. Okay? Well, if we put in -2 in for that, we have 2 to the -2. And how do we evaluate that? You know that negative exponents actually cause the whole power to be brought down into the denominator. So this is actually 1 over 4. So it's 1/4. And notice that this point right here, if we draw this right here, see this would be -2 on the x-axis would have a y value of 1/4. So something pretty small. This is exactly the scale, but you can see how that would be pretty small. That's why these values are small over here. Obviously, a -5, right? A -5 way over here would be 1 over 32. So that's why it gets super small. Now, if we had 2 to the power of 1, that's obviously 2. 2 to the power of 3 is 8. And so here we're building this graph where we have 1, and this should be 2. Again, sorry, my graph is not exactly the scale, but 3 should be 8, so this actually should be a little bit steeper here, I guess, but you can kind of see how this is built, all right? Okay. Everyone understand that? Okay. Any questions about that? All right, if we go back to your text here, let's just kind of zip through here. We won't do that example, but so here we have in your text right here an exponential function, y equals c to the power of x. Now, this is a typical exponential function. It's exponential growth. It's an increasing exponential function. It's increasing. Why is it increasing? As you move from left to right, the y values always get larger. Okay, so it's increasing. This one is decreasing. And if you look at this graphic right here, what makes it decreasing? What part of the equation makes it decreasing? Anybody? Well, if you look right here, look at C. Here are the restrictions for C. Look at C is greater than 1 over here, like y equals 2x, right? If C is between 0 and 1, then you have a decreasing function. So let's confirm that on your calculator. Go to your y equals, all right? And pick a number, it doesn't matter what, but use your brackets there and do, let's say 1 over 2, so 1/2. And then bracket to the power of x. Okay, try that one. And you can graph them both. But you should see, look at that. There's an exponential function because x is in the exponent position, but it comes down. This is a decreasing one, and if you look back over in your book, that's what it's saying, when c is a decimal between 0 and 1. Okay? So it's some kind of fraction there. Okay, everyone see that? Any questions there? Okay. Why, look at this question right here in your text. Why is the definition of an exponential function restricted to positive values of c? Anybody answer that, or anybody have any ideas? What if, well, let's try it out. So let's say this one here, let's try -2 to the power of x. Let's see what the big deal is. And we'll clear the other one. Let's see what happens there. Obviously we got some kind of issue here, don't we? -2. So what is happening? Can't see anything. Well, let's go back to our table of values. Let's just see. So if we had xy, I'm sorry, my messiness, I'm going to do this real quick, but what happens if we had -2 to the power of x? So let's see, a -1 would be what? If x was -1, what's -2 to the power of -1? Well, that's 1 over -2. So it would be -1/2, right? So what about a +2? What about a +2? Well, that's -2 to the power of +2, which is 4. Okay, I don't see what the big deal is there. What about 3? Oh, I see a problem. What is -2 to the power of 3? Okay, it's not 6, unfortunately. It's to the power of 3, so that is actually, it's 8, and it's negative. So what I want to show you here is that these values are going to be popping back and forth, negative, positive, negative, positive. So instead of having a continuous line of points, what we're going to have is we're going to have something like, something like this. we're going to have a point here and a point there and a point there and a point there and a point there and a point there. That's not a graph. We're not talking about, you know what I mean? We've got issues here, right? Actually, it's going to be like this. You see that? It's going to be positive, negative, positive, negative. So if we have a negative c value, we are not going to get a typical exponential function that we can use in science and math, one that's predictable. Okay? So actually on your calculator there, probably what's happened is the points are there, but they're not together forming a line, so you can't really see them, I guess. Because if we did a table, let's see. Okay, look at negative, positive, negative, positive, negative, positive, negative. See? Just keeps going back and forth. So no good. Good with that? So we'll keep C being positive, and then we can actually see this sort of shape that we're looking for. All right, so that's huge. That's huge. Whoops, where am I going? This is huge right here. Okay, the general shapes of the graphs. Notice that 0, 1 is the y-intercept for all this, everything in this section. Okay? All right. So we're getting close to the end of class here. What I'd like to do, let's just head to the assignment here. Okay? So again, in your textbook here, it talks about exponential growth, which I talked about. I talked about exponential decay. All right. Half-life is also something kind of science-related, which you can read about. Okay. So I'm going to get you to do some basic questions here, and there are the key ideas, okay, from the text. And what I'd like you to do, okay. Okay, I'm going to get you to do 1 to 4, okay, 1 to 4. And I didn't do an example like number 4, but you can check your text, look over that example. What you're doing is you're building the equation. You're trying to figure out what c value to use. That's it. So write your table of values if you want, see if you can find a relationship here, and you are writing the exponential function yourself, okay? So 1 to 4 is your assignment, and we will pick this up next class.